everyone, good morning. Welcome to Global AppSec Amsterdam in general, and welcome specifically to the OWASP project showcase. For those of you who are attending the first time the showcase, this is the track where project leaders have a chance to show what we're doing, and hopefully by that get comments and involvement from the community. This here is the API security project. It was founded and sponsored in the beginning by Checkmarx and Salt, and this is the last commercial slide, so let's move on. Project leaders are myself. My name is Erez. I work at Checkmarx for 5 years now. I'm Director of Security Research, focusing mainly now on application security, obviously. Strong believer in spreading security awareness, and my superpower is that I see a lot of mistakes out there all the time. Inon Shkedy is the nice guy sitting here. He's the head of research at Traceable AI, 7 years of research and pen testing experience. And his superpower is that he grew with APIs, so he sleeps, drinks, eats, and dreams API. Okay, so let's start with the question. What is an API? API stands for? Okay. I heard you mumbling, but if I connect the words, I think it's application programming interface, what you said. So we went to the Holy Scripture, Wikipedia, and found that the general definition is an interface or communication protocol between a client and a server, which we know that, and it makes sense. Who uses APIs? Everyone and everywhere, right? So I try to put all the buzzwords I know here. Seriously, every modern application uses it. It's excellent for mobile and IoT and B2B and serverless, so everything that is cloud these days, single-page applications, really everything is dependent on APIs. API is the beating heart of every modern application, and we love it. It's really helping us to develop, to put more attention on the business than the programming. So when we say API security, what we actually mean is API-based applications security. We're looking at modern application security. Today, I will try to show you how API-based applications are different from, we will call them here, traditional applications. Out of that, I hope I will convince you that it deserves their own project. I've discussed a bit about the roadmap of the OWASP project. I will let Inon to present, not in depth, but more than a few words for every one of our API security top 10 release candidates that we released recently. Some acknowledgements, and then I will cry for help in the end. So let's start. How API-based apps are different. So all of us know that in the past our client was a web browser. Basically, this was the limitation. There were some different clients, but basically this was the client that we talked about. Today we are wearing the clients, we're talking to the clients. It could be mobile or smart toaster or watch, bot, whatever you can think of is the client now. So it's very varied, and they get stronger also. They have more CPU muscle. This made the logic move from the back end to the front end, to the client side. We don't expect the server to know where the information goes to, which client it is, although sometimes there is some knowledge transfer. But we expect the client to take the information and present it in a way that makes sense for that specific client. So this move was a business choice, but also it brought some vulnerabilities with it, and we'll discuss that. So let's look at the flow of information as we see it in traditional applications and modern applications. So let's start with the similar stuff. A user will contact some sort of client, and then we'll get information from that client. The user does not need to know what happens behind the scenes, obviously. We don't expect him to, and that's okay. In traditional application and in modern application, there will be a server connecting to a database. Hopefully in a modern application it will not be the traditional SQL, but some sort of Elastic or NoSQL, but basically it works the same. And we'll get the data from that. And here starts the part that is slightly different and makes all the difference, basically. In a traditional application, the client will send a GET request. The server will make some sort of processing and get a fully rendered HTML to the client. Of course, this is very simplified, but basically this is the schematic process. In a modern application, an API GET will be sent, or API GETs will be sent to a server. The server will say, okay, here is what you asked for, this is the raw data. And then we would expect the client to make some sort of processing, logic steps, parsing, whatever, and present it to the user. It's very simple to understand, and everyone who actually uses the APIs and modern application knows how it looks like. There are less abstraction layers that way. The client and server and also database, they speak the same language, usually JSON. It's the most comfortable one at the moment. So the server is used more as a proxy for data. The rendering component is the client, not the server. And it means that clients consume raw data, as we saw. It means that the APIs themselves, they expose the underlying implementation of the app. Sometimes you actually see the API and you understand what's going on behind the stage. And the user state is usually maintained and monitored by the client. The last issue here is that more parameters are sent in each HTTP request. This is part of the sending of the raw data. So you have object IDs and filters and everything, sometimes more than you actually need. And I see many of you nodding for what I just said. Okay, let's talk for a second about the REST API standard. It's excellent. It's really good. I think that everyone who adopts it finds all the good things about it. It's standardized and generic, but also it's standardized and generic, which means that it's predictable. It has predictable entry points. One entry point can be used for multiple purposes. But there are also good news. I don't want to leave you upset here. So traditional vulnerabilities are less common in API-based applications. SQL injections, for example, less common because of increasing use of ORMs, and we'll talk about it a bit later again. CSRF, less common because of cookies that are making place to authorization headers, slowly but surely. Path manipulations are very different now with cloud-based storage. It's not that they don't exist, but they exist less, and the severity is very, very different. And also a plethora of classic IT security issues are being handled by modern SaaS. Let's look about any DevOps here. Just one? Where are all the DevOps? Okay, DevOps also see the issues here, they see the problems. You look at CI/CD, APIs change all the time. When you look at Kubernetes and different Dockers and everything cloud, it takes just a few clicks to spin up new APIs. It's really too easy. Sometimes it's way too easy for our own good. What it means that APIs became hard to track, and if something is hard to track, we don't track it. I think we all know that. It causes shadow APIs, it causes old exposed APIs, and we see it all the time out there. So let's talk about our project for a second. The project starts with the API security top 10. We started with it because it made more sense to see where we need to start and put our focus on. The next step will be API security cheat sheet, where we put all our all the issues that did not get into the top 10, and hopefully try to create some sort of a checklist for developers. And the last part is the one I love best. We call it Crappy. I think it's a very good name. It stands for Completely Ridiculous API, and it will be an intentionally vulnerable API project because developers like to see bad code to understand it. And I know that. I used to be a developer, so I always look for the code and not the documentation. At the moment, we are here. We're supposed to release version 1 now of the top 10, but it's going to be pushed, I think, a month forward because only now the community is starting to get some traction about it, and we're starting to get some comments. I'll show you how to do that in the end. So we do want to hear everyone before we finalize the version 1. So what I'm going to show you today is the release candidate, which we feel very proud of, and already the community gave a lot of feedback about that. I think it's the end result of 20 or 30 different people from different companies and independents. The cheat sheet will start soon, and Crappy will start just a bit after that. I'll show you how to check our announcements. If you want to join us, please do. The creation process, it was not very easy because we could not find any real data aggregated for API issues only. And also when we did a call for data from vendors, no one really replied. So we used our internal knowledge and experience. We did some internal data collection from many bug bounties reports, published incidents, etc. And did some call for comments, and everything ended up as this top 10. So I will read it quickly so you get used to the words, because some names here are new and very specific for the API top 10. So you need to get used to them and spread them around. A1, which we will probably change to API 1 because it collides with the OWASP top 10, the traditional top 10, let's call it. So we have broken object level authorization, or BOLA, broken authentication, A3, excessive data exposure, 4, lack of resources and rate limiting, 5 is broken function level authorization, 6, mass assignment, 7, security misconfiguration, 8, injection, 9, improper assets management, and 10, insufficient logging and monitoring. And I will give the stage to Inon to discuss a bit about each and every one of them.
Hey guys, so first of all, thank you all for coming. My name is Inon Shkedy, and just a few words about myself. I started my career back in Israel. I was part of the red team of the IDF, which is the Israeli army. I used to work with many government, military, and financial organizations. And as you can imagine, I saw mostly traditional applications, more like SPX, SOAP-based, and very traditional concepts, like multi-page applications. I didn't see a lot of CI/CD, and the APIs were used mostly for like B2B communication, based on SOAP. And 2 years ago, I bought a one-way ticket to the Silicon Valley in California, and I started a new journey. And I've been working mostly with the startups and T1 companies. And I started seeing a different type of applications, more like modern applications, with new concepts like CI/CD, cloud-based. And I found many of the traditional vulnerabilities I used to see, like SQL injection and CSRF, and things in this field, are less common in APIs. And I had to adapt myself. And this is one of the sources for data for this project. So before I start talking about each one of the issues, let's talk about the biggest challenge we see today in APIs, which is authorization. So both A1 and A5 talk about authorization issues, or access control issues. It's the same thing. Why is it so common in APIs? So first of all, if we talk about authorization, it's not just a single component, like authentication. It's something very spread in the API. You can find it in many components. It can be in the code level, in almost every controller. It can be in the configuration, and sometimes even in the API gateway, or in components between the client and the API. And the second, it's a very decentralized mechanism. And the second point is if we talk about modern applications, you can find many types of users, many rules, and many users. And you can find also like some weird situations that you can see, like the user Hugo that has 2 sub-users, or the user Shredder that belongs to 2 different groups, like drivers and admins. So it's really hard to create like a good authorization mechanism APIs. It's a big challenge. The first issue is broken object level authorization. You probably know it as IDO, Insecure Direct Object Reference. We decided to change the name because of a few reasons. I'm going to talk about this shortly. But let's try to understand what is BOLA. So you have some ride-sharing app, and it exposes the feature to rate a specific ride. But you've taken many rides. And in order to perform this action, the client application would send a post request to API/trip/rate trip. But it has to mention the trip ID, the ID of the ride. And then the API performs this logic. It finds the ride by the ID. But if the API doesn't implement some logic to validate that this ID belongs to the login user, it's vulnerable to BOLA. And it means that one attacker can just send many requests with different IDs and change all the rates of all the rides in the API. So why we change the name from, by the way, this is the most common thing in APIs that we see today. This is like by far the most common vulnerability in APIs. So why we decided to change the name from IDO to BOLA? So the name IDO, Insecure Direct Object Reference, is a cool name, but it's not very accurate. Why? Because the problem is not about the ID, it's not about the object reference, it's about lack of authorization. So what solutions are not good to solve the problem? So GUIDs instead of numbers, it's another layer of protection, but it's definitely not a mechanism to solve BOLA. Indirect object reference doesn't really work in APIs. If you ask your developers to implement insecure indirect object reference instead of direct ID, they would tell you no way. Because APIs today receive many IDs. It's part of the REST standards. Also, relying on IDs from the JOT tokens, it solves only one type of BOLA. Basically, in BOLA you have 2 types. The first type is based on user ID, which you can solve by comparing the ID from the JOT token. But there is a different type of BOLA, which is based on object ID. And the object ID can be many types of objects. Like in Uber, it would be a ride, it would be a receipt. And you can't really store all the IDs for one user in the JOT token. Solutions that actually solve the problem is, first of all, you need to implement a good authorization mechanism. And the good authorization mechanism relies on the business logic. It's very different than app to app. For example, in Facebook, think about the logic to validate that one user has access to see a specific post. It's very complex. I can't really tell the developers how to implement it. It depends on the logic. And more important than that, many of the companies that get breached today by BOLA, they have a good authorization mechanism. The problem is that the developers don't use it. So they just take the ID and fetch it from the database. So you need to make sure that developers actually use it in every controller that receive IDs from the client. Just a cool example from, I think it was a few days ago. The Anand Parkash from AppSecure found a way to get full account takeover for every Uber user. He found an API that receives a user UUID. By the way, as you can see, this is a GUID. It's not something that is easy to predict, but he found another endpoint that exposes IDs of other drivers by email or phone number. And then he made an API call to get consent screen details. He sent the ID of the other user, and he got a full JSON that contains all the details about the user, including authentication token. So basically, full account takeover. Let's talk about A2, broken authentication. So it's basically 2 different types of problems. The first one is a lack of protection. So you can see this API. It exposes 4 different endpoints. You can see the picture and get location. They have nothing to do with authentication. So it's enough to implement some basic rate limiting mechanism for them. But then you have the forgot password in the web logging. And these 2 endpoints, you should think about them as assets that need to be protected. And it means that you need to implement some extra protection for them. And extra protection means account lockout. It means that after a few attempts to log into the same user with wrong passwords, you need to lock the user for a few minutes, or maybe to return a captcha to the client, or brute force attacks, like protection against credential stuffing. And the second type of vulnerabilities is misconfiguration. For example, job tokens allow algorithm none, so you can just sign the token yourself, or tokens that don't expire, things like that. An example from like about 1 year ago from the same guy, Inon Shkedy. It was on Facebook. They have a feature that allows you to reset a password of a user by the phone number. So you put the phone number of the user, and the user would get a token in an SMS, and then this token is basically 5 digits, and it's like a reset password token. And it's about 100,000 options. So the guy said, okay, let's try to brute force this token for a user. So he tried to reset password for another user and then to guess all the options. So we tried it on Facebook.com, but they implemented like lockout mechanism, and after 10 attempts, this token got revoked. But then he found beta.facebook.com and mbasic.beta.facebook.com. Both of them didn't implement this specific lockout mechanism, and he was able to basically get full, it was full account takeover for every Facebook user. A3, excessive data exposure. It's one of my favorite vulnerabilities. Instead of performing like a complex pen test and try to be very creative, you can just take a look at the traffic between the client and the API and to see private data of other users. Basically, the APIs expose the private data of other users by design. So just an example how it looks like. You have a dating app, you can see the profile of Bob, which is a minion. You can see his hobbies. By the way, I would swipe right for sure. And then if you take, and all of this data are basically public data about Bob, like name and hobbies. But if you take a look at the traffic between the client and the API, you can see the following pattern. The client would send a request to the API, like get/user/717, which is the user ID of Bob. And then the response contains all the public data, like profile picture and name, but also the address of Bob. So the developers basically the developers in the backend send all the data to the client, and they rely on the front-end engineers to filter out this data. So you can't really see it on the app itself, on the client app itself, but if you sniff the traffic, you can easily see it. So filtering sensitive information on the client side is always a bad idea, but it happens a lot today. Why? The API economy and the REST standard encourage developers to implement APIs in a very predictable way, in a very generic way. So one endpoint can be consumed by multiple features or clients. So many times they choose to use like some type of 2 JSON functions from the ORM and model, and they would just return the whole object to the client. And without really think who is the consumer of the data. Just a cool example for A3 from the Tree Fun app. This is an app that allows couples, swingers, to find other couples.
Who knows this app? We don't judge.
It was found by Alex Loomis from Pentest Patterns, and basically he found that doing after you run the app for the first time, it would send a request to match users, and you would get a list of all the users around you. And some of the details are public, but some of the details are private, like private photos and specific. Oops. Didn't know it's touch. Very impressive. So on top of the public data, you could find private data about the users in this API call. And he actually wrote a script to map all the users around the White House based on this data. A4. Lack of resources and rate limiting. It might lead to denial of service. And a good example from APIs is that you have like an endpoint that exposes you all the users on the website, like a list of users. And then instead of sending like a small number, like between 1 to 100, you'd send like a very large number. and it would make the API work really hard to fetch all the data from the database. And it can lead to denial of service. A5, another authorization issue, which is this is broken function level authorization, BAFLA. And let's say that you have an API that exposes a few sub APIs, like admin API, others API, and drivers API. Like this is the API of Uber, for example. And then from the admin panel, the admin has the option to delete a specific user. And the API call that would be performed behind the scenes, it's delete /users /717. This is the user ID of Bob, by the way. And this is okay, because this is an admin account, and he should be able to delete the user. But then, an attacker can send the same API call to delete the user, and because the API doesn't validate that the user belongs to the rule of admins, it's vulnerable to function level authorization, a broken function of authorization. And basically, this way, the attacker can delete all the users on the API. So, why is it so common in APIs to find it? It's not a new vulnerability, but it became much more common in APIs. So, it's easier to predict the endpoints in APIs. What does it mean? Let's talk about traditional applications, for example. And you have a feature in some old application of fetch users profile. It would look something like get/app/usersview.aspx, and you would send the user ID in the get parameters. And then you have a feature that should be exposed only to admins, like delete user. And the structure of this endpoint, of this entry point, is very different than this endpoint. So attackers might see this pattern because they have regular user, but they don't know, this is like a secret. They need to know what is the entry point to get to this admin function. And this is like app/admin panel/user management.aspx, and you need to mention the action in the body and also the user ID. It's really hard to predict it. So even though if the developers didn't implement the function level authorization, it would be hard for attacker to predict this endpoint. But then in APIs, it becomes really easy. This is an endpoint to expose details about specific user, and this is an admin endpoint to delete this user. The REST API encourages developers to develop APIs in a very generic and predictable way, and this is why it's much easier to exploit BAFLA in APIs. A few words about function level authorization. First of all, it can be implemented in different components in the app. It can be implemented in the configuration, in the code, and also in the API gateway. And you have different roles in modern APIs, like admins, super admins, driver, riders. It's very diverse. An example from Shopify, UZ Sunny got 20 grants in bounty from HackerOne because he found a way to create some type of an admin account on Shopify on every shop. It's called a collaborator. And this was lack of validation of the user role. A6, mass assignment. Before we talk about mass assignment, let's look about a flow in traditional applications, how to create a new user. So the client would send an HTTP request. This is not an API, this is a traditional application with all of the data of the new user, like Inon Shkedy and the password. And then the developers would fetch each one of these properties into variables of like the new object of the user. And they would create a very specific user object on the database because they take only specific parameters from the request. This is not vulnerable to mass assignment. But now, in APIs and modern applications, modern environments like Ruby on Rails and Node.js encourage developers to use mass assignment. So what is mass assignment? The client would send a JSON object that contains all the details about the user, about the new user, like last name, first name, and password. And then, instead of extracting each property from the client, the ORM does some black magic and just converts this JSON to an object in a database. So this is very convenient. Instead of 6 lines of code, the developer can use only 1 line of code. but it exposes the API to a new type of vulnerability, which is mass assignment. And basically, the same way I could update the last name and the first name, I can update every property that belongs to the same object if they don't have the right protection. And it's very common in APIs. So, for example, this is a legit request of username Inon and password 126. This is a malicious request. I can also update some property of the object I should not have access to, like the role of the user. So I would create to myself a new admin account. Why is it so common in APIs? So it's not a new vulnerability, but it's easier to exploit mass assignment in the APIs. Why? Because the APIs expose the underlying implementation of the app. What does it mean? Let's say that you have this endpoint that is vulnerable to mass assignment. It allows you to edit every property of a video object. So in traditional applications, if you saw that, how can you exploit mass assignment? Mass assignment is a bit tricky vulnerability. You need to understand the business logic of the app in order to exploit it. There is no only one way to exploit it. It's not like a SQL injection. So how can you how can you assign a new internal property to the video object in order to exploit the API? It's not very clear. You need to get some more detail, more information, internal information about the app. Fortunately, APIs expose this information. So I would just find another endpoint of get video files of the same user, and I can see all the properties of the same video object. And as you can see, one of the properties is the convention params. It's something internal for the API. Probably in traditional applications, I couldn't even know about this property. But because APIs just expose a lot of data, I could see what is this parameter. And the next thing I would do, because it looks like something that goes into a shell command, right? So the developers probably use this in order to convert the video file. So the first thing I would do as an attacker is to concatenate a shell command and to perform shell injection. And this is something that it would be really hard to exploit this vulnerability in traditional applications. This is an example from New Relic, some attacker, James Kettle from Port Swigger. This is the company of Berg Suit. He found a way to enable API access for free users, even though they shouldn't have the access in New Relic. And it was done just by adding like this allow API access to the request. A7, security misconfiguration, is basically a bucket of bad things. It's a combination of many different things about APIs, like lack of CSRF and CRS protection, lack of security-related HTTP headers, unnecessary exposed HTTP methods, and weak encryption, and many more things. A8, let's talk about injection. Injection used to be the most common vulnerability for many years. So we moved it from A1 to A8. So why did we do it? And in order to understand it, let's ask ourselves, what is the reason that injection was A1 for so many years? So we believe that the reason is because of SQL injections. This was the most common vector for injections. SQL injections are not very common as they used to be in APIs. Why? There are three main reasons. First of all, developers use ORMs that solve most of the type of SQL injections. Not all of them, but most of them. By the way, do you know what is the reason that developers use ORMs? Not because it's secured, just because it's more convenient. And the second point, there are so many solutions that solve SQL injection, gazillion of them. And the third point is the use of NoSQL. NoSQL injections are still a thing, but they are usually much less severe and common. A9, improper asset management. So it contains two subtypes of vulnerability. The first one is API endpoints with no documentation. So this is more like from the developer's point of view. You can see an API that exposes three different endpoints. The first one is get user, the second one is object location, and both of them are documented. The developers use like OpenAPI or just regular documentation in order to document each one of these endpoints, which is cool, it's good. But then you have some old endpoint of VO/V2B underscore old, export all users. By the way, this is a real endpoint I saw in like some financial application. And nobody knows about this endpoint. The developers didn't really write any documentation. Maybe some developer implemented this function many years ago, and they forgot to document it. So nobody really knows about this endpoint. And the second type of improper asset management is unknown API hosts. So we can see that the company has payment API and mobile API, that the DevOps teams know about these APIs, but then you have some QA-3-old API. And if you ask the DevOps guy, what is this API? He will tell you, I'm not sure, it's something that we don't want to remove, it's something old, but we don't want to remove it. And it opens like a door for many problems. You need to keep on track with your APIs. Why is so common APIs? So first of all, because of CI/CD. APIs change all the time, and developers focus on like delivering and not documenting. And the second point, it's because of cloud and deployment of automation like Kubernetes and Docker. It makes it way too easy to spin up a new API. So DevOps engineers can just spin a new API every day, and it's really hard to keep on track on them. With them. A10, it's the same thing as the OWASP top 10 for 2017. It's basically insufficient logging monitoring. You need to log all the malicious activity in your APIs or all the errors in order to be able to see attackers. Okay, that was the top 10 list.
Okay, everyone wrote everything down. So actually, we never discussed it before, but let's raise the subject. I'm assuming everyone here is going to rush home or to work and try to fix their API securities. Some of them will be nice enough to wait until the end of the conference. What would be the first thing they should do? I think that the first thing I would start with would be A9, because it seems like very, very basic housekeeping to start and understand what you have under your hands. What would you start with? What would be your top two? Okay, top two, not in severity like this list, but in what the things to start with.
Yeah, I think it would be very important to understand the authorization mechanism in the API, and to start talking with the developers and to understand how does it work behind the scenes. How the API validates that one user has access to one object.
Okay, cool. So we see eye to eye here. So yeah, basic housekeeping is probably the less fun thing you can do, but probably with the best ROI. So I'm sure all of you want to be part of this project. As I said, we're just beginning. This is the right place for discussions. Either here or on the Issues tab in the GitHub project that I'll show you in a second. Oh, cool, I see cameras. More cameras? Mm-hmm. Excellent.
And is there also Slack on a OWASP Slack channel?
Yeah. That's
mention
also,
this, please.
Right. We have the project itself for those of you who are not afraid of PRs. And again, the issues there, we answer each and every one of them, and everything is considered in that. Also, there's obviously the Slack channel, the OWASP Slack channel, and also the OWASP official page for the project, where we will publish this presentation, and also all the announcements of when we start the next phases of cheat sheet. If you want to join Crappy, if you want to design some very bad software. And oh yeah, that's the web page and the GitHub, and that's it. We really want to hear more and more comments and feedbacks about this list. As I said, it's the result of 20 or 30 different people pushing more and more content and changing it all the time. We're really close to finalizing it as version 1. We'll keep it still open for the next couple of weeks. I'm not sure how many will make sense. We'll see as we go. And we want to hear as many opinions, either positive or negative, we can handle it. That's fine. So, questions? Yes.
So your A1, A5, and A9 all your aligned. What do you have A1 and A5 as a